So this is the video 7 for the Posicast control journey. We are going to see how to incorporate the PID control with Posicast. This is part 1. So there is several ways to incorporate the Posicast with feedback control. The first one, we are going to call it here the case 1. Posicast as a reference input pre-filter. So the Posicast is here in the outside as a pre-filter to the reference input. This is the first approach. The second approach is we insert the Posicast inside the closed loop, feedback loop here. So this is the second approach. The third approach is a dual mode configuration. So in this case, this was proposed here in this paper. We have a switch here that is going to switch from manual control to automatic control in a predefined switching time TS. So the objective is to use the Posicast to put the output of the control output in the set point value, and then when the system reaches the steady state, we switch for automatic, and then we use the PID control for disturbance rejection. So we are going to first to see the case 2, Posicast inside the control loop. So this was, in this case, the Posicast is represented here. This in this case is off-cycle Posicast, and we have proposed a way to, so the K1 is determined in the same way from the overshoot, and the TDP here is the peak time, as you have seen before for the off-cycle Posicast. So in this paper from Tabi Vranchik and myself, we have proposed this technique to estimate for higher order oscillating process, a simple way an heuristic way to determine the K1 and the TDP, or the peak time. So the K1 can be estimated from this D1 and D2, and the TDP can be evaluated subtracting T2 from T1. So this was a way to estimate these two variables. Then this was the process was modified, and we have to check the paper to see how to the modification is incorporated in the PID controller design technique. But here we have a simulation for this model, a third order model with a delay, and we have represented here the open loop. This is the open loop response without Posicast and with Posicast term, and using that heuristic rules that I showed you before, we can estimate D1 and D2 as these ones, and the TP as these 4.51 seconds, and so with these ones we evaluate K1 and this time delay, and using these two, and then using the MOMI technique, we can evaluate the PID gains, and with these PID gains we have the response here. We can see here in the control signal the two control signal is changed with the Posicast. Here we got the output of the system is not, it has a little bit of overshoot, but still is a nice response. And now I'm going to change for the dual mode configuration. This dual mode configuration with anti-windup was proposed here in this paper in the PID 2012 in Brescia. And okay, I'm not going to explain in detail the control loop, but you can see here that we got here the Posicast. Here blue, this is the half cycle Posicast. And then we got here the PID controller with anti-windup. And we got here the switching time with TS. So the principle is the same. We are going to use the Posicast to put the control output in the reference set point, and then switch for PID for dealing with disturbance rejection. So once more, we are going to use the simple second order model, this one. So the half cycle Posicast, we can determine the amplitudes of the steps, and so this results in this half cycle transfer function. And the PID tuning, you can see the paper for details. It results in these three gains. So we have here the response. So we can see here in this black dashed, we can see this is the PID without any Posicast. And then we can see here the PID in red with this is the PID with Posicast. Still, we got here a problem because of it is not implemented the anti-windup, and so when you implement the anti-windup, you can see that this is really here a perfect, almost perfect deadbeat response, and that you got here the load disturbance. So in this case, the switching time it was equal to 4 seconds. So we have to wait until it reaches the steady state. In this case, it was quite soon, and then we switch for. So this is the half cycle, the Posicast, and this is from here is the PID control. Okay, so this has advantage and disadvantage. So, but it works in simulation. Okay, then later on, we have proposed this technique again with for more sophisticated for the switching to determine the switching. So we use the reference and the output to determine the switching time. And in this case, this was published in this paper. The problem in this case, because the system cannot be represented always as a second order underdamped system, it can be high order or it can be a different with different dynamics. Sometimes this using these three steps, Posicast, this T1 is not always half of T2. So the question is how to determine T1 and T2 for those systems who are not perfect under the second order, underdamped systems. So in this case, we use this rule. So T1 is going to be a ratio of T2 using this beta. So we use an optimization algorithm. In this case, it was the particle swarm optimization. So each particle of the swarm represents a candidate solution for the control design. In this case, the control design involves this A1, A2, the constants for the A1, A2, and A3, and also involves the T2. So if we decide the T2 and the beta, we have all the details for the three-step Posicast. I'm not going to go to details about the particle swarm optimization, but you can find information in YouTube about that. So in this case, using a digital implementation, we have here two simulation cases. The first one is a standard second order underdamped system with this damping factor, with this and with this natural frequency. This is the sampling time, and with this we designed the off-cycle Posicast in the digital domain and the PID controller, and this is the response. So we can see here that clearly we got here the off cycle, as you can see here, and then we got we switch for PID controller, and another step for, because in this case we got two types of disturbance, this one and this one. So this is also for the three-step design from the same system. You can see here quite nicely the up and down, the three-step response, and also the PID acting. And finally, it is with a first order plus time delay that in this case it is not a second order, but it is modeled as so. In this case, the off cycle, the controller, the Posicast controller was this one, and the PID gains were these ones, and the response was this one. So in this case, it is nice to see that it just goes up and comes down to this point, to this reference value, and you can see also the disturbance rejection. Okay, so with this simulation, I conclude the video 7. I hope that you enjoyed. Thank you for watching.